Hey, everybody, welcome back. So for this session, we're going to be looking at functions, and let's go ahead and jump into it. So functions are pieces of code or logic that are broken out into named bodies of work. And we've been using functions since the beginning of our sessions. The most common one is likely the print function. So the print is a built-in Python function that outputs to the standard output and accepts values or a value or multiple values, a separator, an end, and some other things that really aren't that important right now. The two here that we haven't really covered are the separator and end. So to indicate that, hey, I would like to take my values, output them to the console, but I want them to be separated by commas or spaces or new lines or whatever the case may be. The default separator is a space. So that means that if you did something like this, so print 1, 2, 3, you'll see print and it's 1 space 2 space 3. If instead I wanted to use a separator, I could say SCP equals, and then let's just say I want to use a colon instead. So notice here, 1 colon 2 colon 3. The end is indicating that, hey, I would like this to end with blah. And the default end is a new line character. So taking a look at this, so print, and let's just say hello, print world. So if I run that, notice here we get it on 2 separate lines. But on the first one here, I can say, instead of a new line, I'd like you to end with a space. And go ahead and run that. And notice here we get hello world. So that's what a separator and an end are for the print function. And this is just giving you another example of what that looks like. So I'll skip over this for now, but feel free to take a look at it. So when it comes to functions, there's a few terms that you need to know. There's arguments, parameters, return values, function signatures, and scope. So arguments are data or pieces of data given to a function from the caller of the function. A parameter is data received into the function and used in the function. So arguments and parameters are very, very closely related. The return is a keyword used to indicate that data is given back to the caller. A function signature is the definition of your function, which has, kind of made up of multiple parts. And then scope. And this is basically saying the thing that determines whether or not your variables are visible in pieces in other parts of your code. So as a programmer, you get to make your own functions using the def keyword, right? And that's the first part of what makes a function signature. So use def, which means define function. You get to use the function name. So whatever you as the programmer decide that that function's name is. And then the parentheses, and that can be empty parentheses, or it can be comma separated parameters or inputs into your function. So here's an example. So I have the def key, or keyword, sorry, and that's define function. My func is the name, parentheses, param1, comma, param2. So 2 parameters here. Notice the colon on the end of the parentheses, indicating that there's some logic beneath this. And that logic is just a return, and that's returning the sum of param1 and param2. So that is the function itself. And then we have arg1 equals 1, arg2 equals 3, and then we have val equals myfunc arg1 arg2. So what's happening here is I'm calling, or I'm invoking my func, and I'm passing it arg1 and arg2 as arguments. My func then receives the arguments in param1 and param2 as parameters. So that means that arg1, which is a value of 1, is mapped to param1. And likewise, arg2, which is a value of 3, is mapped to param2. So when I return param1 plus param2, that means that that sum is going to be 4. That return gives it back to the caller. So that means that when it comes back, I'm saying val is equal to whatever the return value of my func is, which in this case is 4. So then when I print val, it's going to output 4. When it comes to functions and conventions, we have to kind of follow the PEP 8 guidelines. And per the guide, the function names should be similar to variable names in that they should be snake case. So my underscore func, add underscore nums, calc underscore sales, things of that nature. There's no enforcement of this rule. It's not like your code is not going to work. However, it is strongly encouraged that you use this convention for your function names. So how did Python know that arg1 went to param1 and arg2 went to param2? Well, it's because these are what's known as positional arguments. So the order in which you pass arguments is how they map to parameters. So notice here in my little text blob here on the bottom, I've got arg1 with the position 1, and then param1 is position 1, and then arg2 is position 2, and param2 is position 2. So it just maps it 1 to 1 based on the position they are in inside of the parentheses. So where do things like sep equals space and end equals new line character, like we saw during print, where do those things kind of come into play? These are what's known as keyword args or named args, and they have to be after your positional args. So given our previous function with a little bit of modification, I've got my func param1, param2, and param3. I've got arg1 equals 1, arg2 equals 2, and arg3 equals 3. So basically 1 to 1, 2 to 2, 3 to 3, right? Make this easy. So I'm saying return value equals my func arg1. So that's still a positional argument. That's still going to map to param1. Then we have param3 equals arg3. So I am explicitly saying as the programmer that param3 maps to arg3. And then immediately after that, it's param2 is equal to arg2. So same thing, param2 explicitly maps to arg2. So that when I run this code and it runs line 2, it says param1 equals 1, param2 equals 2, and param3 equals 3. So notice here that simply adding that equals, that keyword notation, I can swap the position in which param2 and param3 should be in, right? So it didn't follow the positional arguments, right? It followed the keyword arguments to map up the parameters. So let's go ahead and do this review activity. So write a function called makeshirt that accepts a size and the text of a message that should be printed on a shirt. The function should print or return a sentence summarizing the size of the shirt and the message printed on it. Call the function once using positional args and call the function again using keyword args. So go ahead and pause the video and take a stab at doing this program. Okay, so let's go ahead and do this together. So I'll copy this out and put it in here. So first thing we gotta do is write a function called makeshirt. So def, so define function, makeshirt. And then it has to accept a size and a text to put on the shirt. So I'm gonna just size and text, right? I can name my parameters just like that, colon. So then what does it have to do inside this function, right? It has to print or return. So I'm going to go ahead and just do the print for now. So print, and I'm going to use the F formatted string. And I'm going to say size equals size, comma, and then text equals text. Okay. Once we've done that, we've completed that function. So now we have to call the function once using positional args. So I'm going to go ahead and say makeshirt. And the size, we'll just put L. And then for the text, we'll put I heart New York. And then call the function again using keyword args. So make shirt. And here I'm going to flip-flop their position. So I'm going to say text equals I heart running. And then I'm going to say size equals, and I'll put medium. Okay, let's run this. And there we go. Looks like everything ended up okay. Now, let's go ahead and do the return instead. So we can do print or return. I'm going to go ahead and modify this to do the return instead now. So on line 6 here, instead of print, I'm going to go ahead and remove the print with its parentheses, but I'm going to leave the F string. And then I'm going to change this to return. So now I need to have something here to receive or accept that return value. So I'm going to say shirt1 equals that, and shirt 2 equals that. So now it's print shirt1 and print shirt 2. And let's see how we did. Okay, looks great. And that accomplishes the task. And then there are some solutions. Feel free to take a look at those. So parameters can also follow a similar syntax to the keyword args, right? And this allows us to create default parameters. So here we have a function called describe pet. The first parameter is name, and the second one is pet type. But notice here we have an equals dog. So that equals dog is basically telling the program that, hey, if I don't receive a second argument to map to this parameter, go ahead and just default to dog. So that when we call it, we say text equals describe pet spot. Spot will map to name. And then pet type is going to default to dog since a second arg is missing. So it'll return this string of spot is a dog, and then it'll print it. So Python has a few quirks that we kind of have to talk about. So the first one I want to mention is the star args and star quargs. These are special parameters that allow you to accept a changeable or unknown number of arguments. I have yet to have a student in class actually use them, so I'm not going to spend too much time on them, but there is a real Python link right there, so feel free to take a look at it. It's an article describing what they are and how to use them. Next is Python a pass-by-reference language or a pass-by-value language? So what that means is that if you are pass-by-reference, you are passing a quote-unquote reference to the location in memory of the argument. And then pass-by-value is passing what looks like a copy of the value of the argument to the parameter. So which is it? Well, the answer is actually neither. So Python is pass-by-assignment. So depending on what kind of argument you pass determines the outcome, how it will actually operate. So if you pass an immutable parameter or an immutable argument, meaning integers, strings, floats, booleans, or tuple, it's going to receive basically a copy, and any changes to it are not going to impact the outside variables. And then we have our mutable parameters, which are going to be our lists, dictionaries, sets. And these can be, when these are changed during the function, right, they can impact the outside variables. And that is because when they are passed to a function, the function receives a memory location of whatever that argument is. So the argument and the parameter for a mutable argument parameter are both pointing to the same place in memory. So therefore, any changes made are made on the memory location, and thus both places get changed. So we'll see an example of that here in a second. So here's an example of an immutable parameter. And in this case, I'm using an integer. So I'm saying x equals 1. I'm going to go ahead and call my function add1 and pass it x. So x gets mapped to the num parameter. And then on line 2, I'm saying num plus equals 1. And then on line 6, I'm printing x. So despite the fact that num is incremented by 1, the argument passed in is immutable. It's an integer, right? That means that there is no change to x based on what happens to num inside the function. So the output is going to be 1. When it comes to the mutable types, though, so the top screenshot here is a list. So my function is going to append a name, right, to whatever list is calling it. So here on line 4, I make a list called John with John and Sarah inside of it. I call add name and pass it that list. And then I print that list. When I print it, it's going to output John, Sarah, and Will. That's because on line 5, when I pass name list, add name receives a memory location and assigns that to names. Names then appends Will, and then that change occurs to the list in memory, right? So that memory location is modified. So names here and name list both point to the same spot in memory. Thus, the change on line 2 impacts name list. The same thing happens to dictionaries, which is the second screenshot here. So here, my function is going to add an employee. So basically, I'll add Will and let's say engineer. I have an employee map, which is John, the manager, and Sarah, the CEO. I'm going to call add employee and pass it employee map, and then print out employee map. When it prints, I'm going to have John, the manager, Sarah, the CEO, and Will, the engineer. And it's for the same reason. When I pass employee map to add employee map and employees, the parameter, both point to the same location in memory. So when something happens on line 2, which is adding a new entry, it impacts both locations. So employee map is updated as a result of line 2. And then when we print employee map on line 6, you'll see all the entries. So it's just something to be aware of when you're passing around lists and dictionaries in your programs. Okay, another review. So first bullet here is one program by itself, and then the second bullet here is another separate program. So write a function that, given a list of integers, it will return the largest number. So I'm going to copy that direction out. Okay, go ahead, pause the video, and take a stab at it. Okay, so hopefully you had a chance to try it on your own. So let's go ahead and do it together. So let's go ahead and make our number list. So I'm going to say nums equals, and then I'll make my list and say, I don't know, 3, 9, 7, 8, 6, 4, 5, 1. Good enough. I'm then going to make a function, so def, find big. And I'm going to say, what do we want for the parameter name? My nums. And then I'm going to call find big here and pass it nums. Okay, so we have to implement the logic now that will find the largest number. So I would suggest making a variable to kind of keep track of what the largest number is so far. So I'm going to say big is equal to, and in this case, I'm going to use the special none type or none keyword here. And you'll see why here in a second. So then I'm going to loop through the list. So for n in, my nums. And then here, I'm going to compare n to the big. So if big is none, or n is greater than big, then big is equal to n. So you might be wondering about the none still. So basically, Python doesn't have a real nice, clean, largest integer that you can use. So you could do something like, I don't know, negative 999,999,999, right? So 999 million, etc., right? And since it's negative, the likelihood is that the numbers that are going through here are going to be larger than it, right? And thus, big is going to equal n, and then 999 doesn't really matter anymore. However, you don't really know that for sure. So that's why I would suggest using none, right? And that way you can say, if it's none, right, that means this is the first time through the loop, go ahead and make the assignment. And then every time after that, it won't be none anymore. We'll be doing this operation to check against. So that's why I suggest doing none. Just on the off chance that the number that you choose, whether it be negative 999 million or what have you, there's not a risk of it being used like anything less than that, right? So like a billion, for example, a negative billion, or something larger or smaller than whatever the case may be. Anyways, so back to this. So I've got this loop set up to go through all the numbers and then find the big, and then I'm going to return big. So I'm going to go ahead and just say big equals, and then print big. So the largest number in there is 9. Perfect. Now, if I'm doing just a simple print and there's no other logic after this, I actually don't have to make a variable for this. I can just call print directly, like so. And that'll work just fine too. Great. Okay, so next we have write a function that, given a dictionary, it will return the value with the lowest integer. All right. So I'm going to make a similar function, but except I'm going to name it a little different. So find small. And then this is based on a dictionary. So let's just say employees equals. So this will be Will, 50,000. Sarah, 75,000. And Mark, and he'll be 35,000. We're going to call find small, pass it employees. I'm going to name that mapping. So we need to find the lowest integer in this dictionary. So we're going to do something very similar, right? So small equals, and I'm going to put none. And then we're going to go through for v in mapping dot values if small is none, or v is smaller than small, small equals v. And then we're going to return small. And then here, I will just output it like so. And there we go. And that is indeed the smallest value. Okay, so that takes care of that. So we have a good and better, and I kind of described the whole negative 999 million thing versus the none. So I'm not going to review that again. And same thing here. Okay, so now we got another review problem here. So I need a program that contains two functions: a function to calculate bonus percentage given the following salary information, a function that, given salary plus bonus, will calculate the benefits given the following info. So a couple of lists here of information that are important. And then after the above calculations, display the total compensation package, which is salary plus bonus plus benefits. So I'm going to go ahead and copy this out. Okay. So go ahead and pause the video, attempt it yourself, and then come back and we'll do it together. Okay, so we need two functions. So let's start off with the first one there. So we'll say DEF and calc bonus based on the salary. And here it's just kind of a bunch of if statements. So if salary is greater than 75, return 0.05 for 5%. If salary is greater than 50, return 0.03, else return 0.02. Okay, so then we need another function that, given the salary plus bonus, will calculate the benefits with the following information. So def calc benefits. And then here we're going to need salary plus bonus. So we'll just call that comp for compensation. And then we have an if else. So if comp is greater than or equal to 100, return 10,000, else return 7,500. Okay, after the above calculations, display the total compensation package. So let's go ahead and kind of write this out now as if a user were going to use this. So we'll ask the user to enter their salary. Oops. Once we do that, we can now do the bonus. So we'll just say bonus is equal to calc bonus salary. And now we need to take the salary plus the bonus to get the benefits, right? So we'll just make a comp variable, and that'll be equal to salary plus, actually, it'll be multiplication. So times 1 plus bonus. And that'll give us the total compensation so far. Then we're going to say benefits equals calc benefits. I'm going to pass in comp. And then once that's done, we can print. I'm going to use the F format for this. Total compensation is going to be comp plus benefits. Okay, and I think that accomplished what we wanted, so let's go ahead and run it. And let's pick a really easy number. So 100,000. Okay, so we kind of follow this logic here. So 100,000 is salary, calc bonus comes up to here. Salary is 100,000, greater than, so it's 5% for the bonus. And then salary times 1.05, so increase it by 5%. So that's going to be 5,000. So total comp is 5,000 at this point. Calc benefits based on the comp. So that would be 105,000. That's greater than or equal to 100. Therefore, return 10,000. So benefits is 10,000. So 105, 10,000 together is 115. Okay, great. And then we have a sample solution. And that is all I had for functions. So I hope you enjoyed this session, and I will see you next time.